Hello everyone, welcome back to the verification lab. This is our second video on practical session where I will be dealing deep dive into SystemVerilog data type. So as of now I will select my simulator as an Unpacked Pro. I will define one module and I will name it as in TB and I will end it with end module. So in today's discussion we will be discussing about like user defined vector type or fixed size data type. So let me go for the fixed type. So it is an int. As of now I am taking an example of an int. So it is 32-bit. So we all know. Let me run this and see if we get any compilation error or not. So you can see clearly there is no compilation error. So the width is 32-bit. So can we change it? So let us try for the fixed type. So I want to like define the width as a 4-bit. So let me run this and see if it is possible or not. So you can clearly see there is an error. So basically we cannot change the width of a fixed width type. So fixed width type are int, integer, like short int, long int, real, and short real. So maybe some more other which is defined earlier. So now we'll be discussing of the user defined vectors type. So one among them is bit. So let me define here. So here also I am going for a 4-bit only. I'm defining my variable as an a. So it is 4-bit. So like the width is now 4-bit. So it is why it is user defined. So let's say sometime we want to change it to 8-bit. So we have to just change the number and it will act like an 8-bit. So you can see there is no compilation issue. So now let me change this to 8-bit and see. So earlier it was 4-bit, now it is 8-bit. Sorry, 8-bit. So basically this is known as user defined vector type. The user can define the size of the vector. So there is no issue. So we can move ahead. So my next topic would be like packed and unpacked. So what are those and how we define those? I will explain. Packed versus unpacked. So I am defining two variable a and b of bit type. Bit. So I am declaring the width as in down to 0 of variable a and bit. I will be declaring the variable as b and like start from 3 to 0. Okay. So basically you can see there are two different things. First thing is the way to declare packed array. The second one is for unpacked. So basically this is for packed and this is for unpacked. So how do we identify this? So in a pack you can see the dimension are before the variable, whereas in case of unpacked the dimension are after the variable. Now like I will try to print the value. I will not store anything as of now. So just to print the value, how we can print. So I am printing the value of a. I'll also print the value of b, but first let me go through for a. So you can see like I have not initialized any value. So like what is the initial value or by default value is there, it will get printed. So a value is printed as in 0. Now let us print the b and c. So let me press run and see. So you can see we are getting an error. The error is basically, you can see if you read this error, it is due to the format specification. So you cannot have decimal format specification for printing the pack. So you have to use one new format specification, and it is with percentage %p. So if you just press run, so you can see like we can print. So percentage %p you have to use. Now we will be moving ahead to see various new flavor of this unpacked array. So as of now, like I have defined it 3 down to 0, and I want to also print the index as well as the what is the value stored in that index. So for this I will be requiring a loop. So I will using for each, sorry, it will be bi, and like it will run p value. I have to print the index also. So our index is, so it will print the index, and v value also it will be printed. So now as of now we want a single value, so we don't need to use p. So first I will give I to, so to print the index, and b I for the value. So let us see. So you can see like for unpacked array, like 3 down to 0, the index starts from 3, and it from 2 1 0, and value is only 0, because like we are not storing any value. I will store the value and I will explain you, but as of now I am not storing any value, and it starts from 3 to 0. Now let us change the index over here, like LSB and MSB. So just 0 to 3. So now let me run. Now you can see my index starts from 0 and ends in 3. So one more way is to, like, you can use for unpacked array is like d, and you write the number of elements. Here we have 4 elements, so you just write 4, and I'll comment this out. So you don't need to mention the range. So if you just mention the number of elements and try to run this, let's see what we get output. So you can see like if we just mention 4 here, it is also working fine. So it starts from 0. Earlier we have the choice, but here there is no choice. Now let me store some value and print. So how do we store value? See here bit is 1 bit. So we can only store zeros and 1. So let us say we want to store values from 0 to 3. So like we will be required 2 bit. So basically I will here define, like it is basically an array. So width and depth. So before variable we define the width, and after variable we define the depth. So width as of now I am taking as in 2 bit. So 2 bit can store like 0 1 2 3. So let me store here b equal to, we will store like this. So 0 1 2 3. So we have stored, and let me print it. So you can see that for 0 index, like 0 is stored, 3 in 1 index 1 is stored. So this is the way, but always remember the largest value should come under this bit 2. So if it is more, like it will get truncated. For example, if we write just 4 here and try to print, because we know 4 need 3 bit. See, the value has been truncated because 4 value need 3 bit and we have only 2 bit. So like what happened, see 0 indexes start from 0 to 3. Now let us say like we will write over here 3 down to 0. Now what will happen? And let me change the value and let me run. So you can see now the index ordering has changed. Now it is starting from 3 and in the third location. So this is the way by which like you can select or declare the dimension of an unpacked array. Now I will move to my next example. So my next example will be bit versus versus byte. So as we know, both are like data type. So if we define here bit 7 down to 0 a, so we have declared an 8 bit. So it is 8 bit, 8 bit. And if we declare byte of b, let's say we have declared different variable, so it is also of 8 bit. So now the question arises, where is the difference? What is the difference we can have? So difference is that we know one is signed and one is unsigned. So I will write u, so you mean unsigned, and I will write here signed. S stand for signed. So unsigned, so it ranges will be 0 to 255, where in case of this its range will be minus 128 to 127. So let us check, let us store the value and display the value and check if it is like satisfying this thing or not. So I'll store some value like a equal to, I'm storing, let's say I'm storing 5. Let me print. So hope to get 5 here only. So you can see the a value is 5. Now let me store here like 255, the uppermost value, and let's see if we can get this value or not. Yeah, it is also 5 as expected. Now let me increase the value and make it as a 300, and let's see now what is happening. So you can see the value is 44, like it is not what is the value what we have stored. So like you have to take care of the width so that you can define the what is the value you can store. So now let us move for the byte and see what are the changes. So what happen if we try to store the negative value also, like -5 or something like that. So let us see. So you can see a different number we are getting. So basically we can't store because whatever we are storing we cannot retrieve, so we cannot store it. So basically this is signed, sorry, unsigned. So unsigned, in unsigned you cannot store negative value. So let me go for the signed one. So -5, can we store it? Let me see. Okay, so basically I have to mention the format here. So let me mention here like 8-bit decimal. So now I will get it printed. Sorry, so I was actually printing A. So if I print B, I think it will get printed. So just 1 minute. Okay. So you can see we can store the negative value in byte. So let us check for the positive value also, like 127. Is it fine to check? So let me run this. So you can see the maximum value is 127. So we are able to store 127. Let us try for 130. So you can see like we are not getting what we are storing. So this is the difference between like signed type and unsigned type. So 1 bit is for position, so the range split up. So how it is splitted up, we have a formula in our theory session. So you can go back to the theory session and like get the formula done. So now I will explain you bit versus byte has been finished. Now I will explain you variable versus lengths. So let me take some examples to explain this. So first I will take variable. So we have a variable as logic reg. So let me take one example as a reg a. So I am declared here. I'll take three initial block. So it is a single statement. So just I am storing value a equal to 0 and initial a equal to 1. Again one more initial to print the value of a. So you can see, just give me a minute. Okay, fine. So you can see like I have taken a reg a variable and I have declared two different value in the initial block. For example, a equal to 0 and a equal to 1. Now I'm trying to print the value. So ideally what it should have some conflict. So let us see what it is happening. So you can see we are getting 1. So there is no logic behind it because both initial line number 11 and line number 14 both initials started at the same time. So it depends upon the tools and simulator. If there is no rule as of such which value will get printed. So this type of issue will happen like if we want to have some multi-driver issue. So this is known as multi-driver issue. But how the net solve it? So if we declare it in OR and like we cannot declare in an initial, so I am commenting this out and I will just write here assign because procedural block continuous assignment we have to use assign statement. So as of now in the same way I am doing like a equal to 0 and a equal to 1. So now let's see. So see there is a conflict and in the conflict it is x. So this is how the net solve the multi-driver issue. Means same value same variable is driven by different value. So if we get an x we get to know that this has been multiple drive. So net resolved has some resolving issue. So there is one chart in the LRM. If you go through the LRM you will get a chart where you can see like for what value how the solving is being done. So now I will move to our next topic, that is reg data type. Sorry, our next topic is real data type. So I will define one variable as a real a. Now like just I want to know what is the size of this real. So how will you get to know? Like earlier I have shown you like we can use size and let me see you can use it here or not. So I will use standard methods size to get the value printed. So let me run this and see what is happening. See, you can see that size is unknown because we cannot print the size in this way. So what to do? Like we have to use one more standard method like we have discussed in the our theory session. So it is real to bits. So we have real value. We are converting it into the bits and the size will calculate depending upon the number of bits. So let me run this. So you can see that we have got the size of a real variable. So that is basically 64 bit. So we have in our theory session we have gone through it is 64 bits. So we are able to get the size. Now I will try to store some value a equal to 2.64 now, and let me print the value. So now I have to remove the size. I have to just write the value of a equal to. So here we have to do some changes with the format specifier. If you want to print the decimal value, like we have to use F format specifier, and we have to name the variable as an A. So let me run right now. So there is some issue. Let me solve this. Okay, so like I have to put on semicolon over here and then run it again. So you can see like we are able to get the value whatever we are stored in. Like now the question arises, like we don't want to get like that much of value. We want just 2 decimal places. So what we have to do? We have to just write over here 0.2 and let me run. So you can see now it is stored as 0.65. So basically it is rounded up. Rounded up, basically 9 is there, so it is rounded up to 5. Like if in this place like we have 4, it will be like 64, not 65. So now it is 64. So what will happen if we have 5 over here? So let me check. So you can see 2.65. So if 5 is there, it will upper cell, it will go to the uppermost decimal value, and if it is like lower than 5, it will go to the lower. So like I want that all the 3 get printed together. Like here we are getting 2 by help of round off, but I want all these 3. So I will just like change this 0.2 to 0.3 and I will press run. Okay, so you can see right now we are getting 2.645. So this is the end of this video. If you found it valuable, please like, share and subscribe to the verification lab, and let me know your thought in comment section, and I will see you in the next one. That's all. Thank you.